We're starting trigonometry in Algebra 2. I believe we're talking about section 9.1. 9.1, and I think we're going to be doing 3 to 27 odds, it looks like. 3 to 27 odds. Trigonometry is a study of triangles. Right now, they're all going to be right triangles. A right triangle has a hypotenuse and two legs. Depending upon where your angle is, the way I have it drawn, this one is the adjacent side, and this is the opposite side from that angle. So you have SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I really need you to get used to writing them in this order. Cosecant, secant, and cotangent to round out the 6 trig ratios. If you put them in this sequence, you'll have them as reciprocals. So instead of opposite over hypotenuse, this would be hypotenuse over opposite. Instead of adjacent over hypotenuse, flip it over, you'd have hypotenuse over adjacent. Instead of opposite over adjacent, cotangent is adjacent over opposite. So if you set your trig values up in this type of a sequence, it can help you keep them straight as far as which are reciprocals to each other. So I set up a right triangle, a 3, 4, 5 Pythagorean triple right triangle, and I chose this bottom angle to be my theta. Greek letters like theta are many times angles. Now I'd like to find the sine of theta, the cosine of theta, and the tangent of theta. All of these are what are called trigonometric ratios. It's a ratio because it is something divided by something else, like the opposite over hypotenuse. What's opposite this angle? Over what's the hypotenuse of the angle? 4 over 5. Whereas cosine is adjacent over hypotenuse. What would that be? Adjacent is 3, hypotenuse is 5. Tangent is TOA, opposite over adjacent. So what would opposite be? 4. Opposite would be 4 and adjacent would be 3. Now if you set it up properly, cosecant, secant, and cotangent, these will simply be the reciprocals. So instead of 4 over 5, it's 5 over 4. Instead of 3 over 5, it's 5 over 3. Instead of 4 over 3, it's 3 over 4. So if you set your trig up in this order or sequence, you'll know which ones are reciprocals of which. Okay, I'm trying to teach everybody how to create the trig table. I put my angles across the top here, first in degrees, and then I put them in red and radians. Now we're going to find the sine of the angle and the cosine of each of these angles. Once you learn how to create this table, you can always recreate it. Here's the procedure. You count from 0 to 4. So I'm going to go 0, 1, 2, 3, 4. Now you're going to take the square root and divide by 2. What's the square root of 0? And 0 divided by 2. Square root of 1 is 1 divided by 2. There's no square root of 2, so it's a square root of 2 divided by 2. This is square root of 3 divided by 2. But what's the square root of 4? 2 divided by 2 is 1. So now you have your sine filled in. Cosine, just reverse the order. The 1 starts with the 1. The radical 3 over 2. The 45 degree is the same. The 1/2, and instead of starting with 0, this one ends with 0. So we've just created the trig table for your first quadrant. The only thing possibly missing from this might be tangent of theta. And tangent is sine over cosine. So if we were to fill this in, let me just take me a minute here to fill in this, make a table here. Oops, come on. Okay, what is 0 over 1? 0. Skip this one in a minute. Hey, what's anything divided by itself? 1. If you divide by 1/2, that means times 2. So that would give you a radical 3. 1 over 0 is undefined. Eventually it might become infinite. And if you do your division here, you'll get radical 3 over 3. Anyway, if you know your trig values in your first quadrant, you can always use those combined with your reference angle to find the trig in any quadrant. So my reference angle's in red. It always goes from the terminal side to the x-axis and is always acute. So if my angle is 120, my reference angle is 60. I look up the cosine of the reference angle and I get a half. Now in this first quadrant, it is positive, alphabetical, cosine, sine. In quadrant 2, it's negative, positive, again alphabetical, negative, and positive, negative. Always alphabetical, x, y, cosine, sine. What quadrant is 120 degrees in? It's in quadrant 2. What sign should the cosine be? Negative. So the cosine of 120 degrees is negative 1/2. Some people teach it with the signs like I do in each quadrant. Other people teach it this way. All students take calculus. All's positive in the first quadrant. Sine is positive in the second quadrant. Tangent is sine over cosine. A negative over a negative would be a positive. And cosine is positive in this fourth quadrant. So you can either learn it as all students take calculus, or you can learn it with the positives and negatives, which is the way that I teach it. Okay, I drew up here number 3 and number 5. I found the missing side using Pythagorean theorem. Sine is opposite over hypotenuse, so I believe it would be 24 over 26. Feel free to simplify that to 12/13. Cosine is adjacent. What's adjacent? 10 over 26. Adjacent over hypotenuse. Tangent is TOA. Opposite over adjacent. Opposite is 24. The adjacent is 10. All of these can simplify, half the top, half the bottom, half the top, half the bottom. Anyway, cosecant is a reciprocal of sine, so you just flip that over, 13 over 12. Secant is a reciprocal of cosine, flipping it over, 13 over 5. Cotangent's a reciprocal of tangent, so if you flip 12/5 over, you'd get 5/12. So anyway, those are your 6 trig ratios for number 3. Now we have to find the missing side in number 5. I have 8 squared, leg squared, plus leg squared equals hypotenuse squared. 121 plus 64, is that 175? I think no. 185? Okay, apparently I wrote this down wrong because the 11 should be the hypotenuse. So now I'm missing a leg. So I could say leg squared plus leg squared equals hypotenuse squared. 11 squared is 121. So you have 64 plus b squared equals 121. If you subtract 64 from 121, we get, I think we get 57. So that makes this side radical 57, right? Sine is opposite over hypotenuse, so I think that's 8 over 11. Cosine is adjacent over hypotenuse, which would be radical 57 over 11. Tangent is TOA, that's opposite over adjacent, so that would be 8 over radical 57. When you rationalize it, you get 8 radical 57 over 57. Flipping 8 elevenths turns it into 11 eighths. Flipping this one over is 11 over radical 57. You can't leave radicals in the denominator, so we have to rationalize it. Same thing here, but it might be easier to flip it at that stage. Radical 57 over 8, and then you don't have to worry about rationalizing. Anyway, there's 3 and 5. Okay, at 9, they give you sine of theta to be 5 over 6, and they want us to find the remaining trigs. So, I have to arbitrarily, first off, do I know that cosecant is a reciprocal of sine?
Yes.
So that would be 6 over 5, right? Where do we wish to put our angle? Because that's going to dictate where we put the 5 and the 6. When you do this, you know that sine has to be opposite over hypotenuse. 6, you have no choice. That's the hypotenuse. But the 5 depends on where you put your theta. If I put the theta here and I want it to be opposite, that would be over here. So I'll probably put the 5 here. So now I have the sine of theta opposite over hypotenuse to be 5 over 6. Okay, to complete this, we need to find the missing side. So legs squared plus legs squared equals hypotenuse squared, right? 36 minus 25, I think, makes it into an 11. So A would be radical 11. So if I wanted cosine, I want adjacent over hypotenuse. So that's adjacent over the hypotenuse, which is 6. Tangent, TOA, opposite over adjacent. If you rationalize, you'll get 5 radical 11 over 11. Flipping the cosine over makes it into 6 over radical 11. I would have to rationalize that to 6 radical 11 over 11. I think it might be easier to flip it at this point because now you'd already have the radical on top. So the cotangent would be radical 5 over 11. And that should be all your 6 trig values. Okay, number 11 says the tangent of theta is 7 over 3. Always draw your picture, draw your right angle so you can tell where your hypotenuse is, and label theta. I usually put it in the bottom corner. Tangent is opposite over adjacent, so 7 over 3. Now the tangent of the theta is opposite over hypotenuse, or 7 over 3. We'll find the missing side by doing legs squared plus legs squared equals hypotenuse squared. 49 plus 9, I think, makes 58, c squared. So radical 58 would be c. So I'll call this hypotenuse radical 58. Now, I want all the trig values. They give me tangent. So they give me the tangent to be 7 over 3. If you know what you're doing, that means the cotangent would be the reciprocal, 3 over 7. And the cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So in other words, if you set it up in this order, it can really help you. Okay, with this problem, we want sine. Sine is opposite over hypotenuse. So would that be 7 over radical 58? If you rationalize it would be radical 58 over 7. And flipping it over would be radical 58 over 7. Because I'm flipping it at that point. Cosine is adjacent, which is 3 over the hypotenuse, which when you flip that becomes radical 58 over 3.
Wait, how come
Rationalizing would be 3 radical 58 over 58. And what happened? What did I do? You're right. There's a little problem on my rationalizing here. You'd multiply by radical 58 over radical 58. And I think you'd get this, right? Okay, what I did was I wrote 19 down here and I put this 30, 60, 90 triangle with its sides underneath it. Over here is a 45, 45, 90 with proportions. However, it doesn't apply to this question. If I look at this one, I notice that the 12 corresponds with a radical 3. So 12 equals a radical 3. To get a, I might divide by radical 3. That gives me 12 radical 3. 12 over radical 3 to equal a. Well, you can't leave radicals in the denominator, so you multiply radical 3 over radical 3. And that makes 12 radical 3 over 3. Does 12 divide by 3? So what is the a going to correspond to here? Would that be 4 radical 3? So I know cosine of 30 would be adjacent over hypotenuse. The adjacent is 12, the hypotenuse is y. And cosine of 30, I know on my trig table, is radical 3 over 2. If you look on your trig table, cosine of 30 degrees. Did we do a trig table here somewhere? Cosine 30 degrees, radical 3 over 2. So I'm going to put radical 3 over 2. Cross multiplying, would this be y times radical 3 equals 2 times 12? So you would get 24 divided by radical 3. When you rationalize it, you'd get 24 radical 3 over 3. What is 24 divided by 3? Hopefully that's the same y value I got using the special right triangles. Now what trig involves the adjacent and the hypotenuse? We found the hypotenuse, I'm sorry. The adjacent and the opposite. Would that be tangent? Tangent is opposite over adjacent. So I could put tangent of 30 degrees equals what's opposite? X over what's the adjacent? 12. What is tangent of 30 degrees on our trig table? I think it's radical 3 over 3. Cross multiplying gives me 3x equaling 12 radical 3. And if I divide 12 by 3, I think I get 4. I believe you're better served at this point using your trig values like I'm doing now on 19 and I'm about to apply on 17. 60 degrees is right up here. Do you agree the 8 is the adjacent? Give me any trig that involves the adjacent. Tangent. Tangent of 60 degrees is equal to opposite over adjacent. Is the x opposite and is the 8 adjacent? Do you know what the tangent of 60 is on your trig table? Radical 3. So if you cross multiply, you would have what x is? What other trig involves adjacent other than tangent? Isn't cosine adjacent over hypotenuse? So what's the adjacent? 8 over the hypotenuse of y, right? So the cosine of 60 degrees would equal the 8 over the y. Look up cosine of 60 degrees on your trig table. Cross multiply, and you'll get y to equal 16. So I drew the picture on 30. They want to know how tall the tree is. I believe how tall the tree is opposite of 31, and the given information is adjacent to the 31-degree angle. So what trig, you have to think on your own here, what trig involves opposite and adjacent? Tangent. So I'm going to type in tangent of 31 degrees equals opposite, which is y, over adjacent, which is 25. Cross multiply or multiply both sides by 25, and you would have this for the height of the tree. Now that's an exact one. When we punch it into our calculator, we're going to get approximate. I don't know why I switched to sign, but it should be 25 times the tangent of 31, right? And when we punch that in on our calculators, we get, at least I get, approximately 15.02151. To the nearest foot, that would be 15 feet.